Okay, that's great. So I'm going to just do a bit of a whistle-stop tour of trig equations, just a kind of a reminder of all the issues at play here. And then we'll take any questions, but also we'll look at some sort of a whole mix of examples. I'm going to start off with kind of what for me would be like the sort of almost the easiest example that I can think of. And that would be something like sine of theta equals -1/2, right? The reason I say it's easy is basically we've just got a trig ratio and it's operating on an angle and we've got a value. Okay, now there are slight different approaches that get used here. The one that I like to use is as follows. So what we're going to do is we're going to find out the size of the angle that gives us a sine of -1/2, right? So what we're going to do, we're going to find what I like to call a key angle or reference angle, whereby we undo sine, right, of +1/2. Okay, and that gives us 30 degrees. 30 degrees is clearly not an answer to this question, because we know that we're expecting answers in the third and fourth quadrants if sine is to be negative. Okay, and now the way we get into quadrant 3, all right, is we will go 180 degrees plus our key. So 180 plus 30, and that will give us 210 degrees. All right. The other one is to go 360 minus 30. So a really big idea here is that we only use our horizontal axis to get into, long day. Okay, I should say theta equals 180 plus 30 or 360 minus 30. Big idea is that to get into the different quadrants with our key, we only use our horizontal axis. Remember, when we come off the vertical axis, ratios change to co-ratios, etc. So we've actually got these two answers. One of them is 180 plus 30, in other words, 210. And the other one is 360 minus 30 or 330. Okay, each of those can have 360 degrees added to them as often as we like. All right, but an important idea is that we actually get two solutions, all right, per 360 degrees. For a vanilla flavored trig equation, we get two solutions per 360 degrees. Okay, I'm saying k is an element of the integers there. All right, so now let's look at something slightly more complicated, but still actually fairly straightforward. Let's look at something like 4 tan theta minus 2 equals 3. Okay, so what we get here now, this is not sort of as simple. We first have to basically get the trig equation, the trig ratio on its own. So we're going to add 2 to both sides. So 4 tan theta equals 5. Now we're going to find our key angle, all right, after we've worked out what tan theta is. Tan theta is 5/4. We know that we want angles in quadrant number 1 and quadrant number 3. Okay, so our angles are going to be kind of in here and here. Our key angle, we're going to undo tan of 5/4. I've come up with a question here that I can't do in my head, so let's just quickly get a calculator up here and shift tan of 5/4, all right, and we get 51,3 degrees. Okay, now the cool thing about tan is that the answers are diagonally across from one another. So this is obviously an answer. This one is 51,3 degrees. The other answer will be 180 plus 51,3 degrees. So in other words, it will be this angle around here. Okay, but if you're wide awake, you'll realize that these two angles that we've highlighted here are actually vertically opposite angles. So that line must be a straight line. When I say that line, I'm talking about this blue line over here. Must be a straight line. Okay. All right. So in fact, our angles are 180 degrees apart. And so for tan, we can just say that our general solution will be 51,3 degrees plus 180. Okay. Right, when we add 180 once, we get this angle over here. When we add 180 a second time, we get the first repeat of our quadrant 1 angle. Okay, right, so these are very much kind of vanilla flavored trig equations, right? Remember we said that there would be two angles per rotation. Okay, let's look at something slightly different now. We're going to look at cos of 2 theta equals negative root 3 over 2. Okay, it looks fairly straightforward, but remember what actually is happening here is that this 2 is going to affect the period of the graph. If we just pictured a cos graph, it would look something like this. With that being 360 degrees. And we can see that if we took a value of negative root 3 over 2, we would get 2 possible answers. When we're looking at cos 2 theta, our graph is actually had its period halved. So in other words, it's going to look at I almost certainly haven't drawn this very well. Okay, it's going to look something like that. We're actually going to get 2 cos graphs between 0 and 360 degrees. And now you'll notice that that has an implication, because now we will get twice as many solutions. We will actually get 4 solutions in our 0 to 360 degrees. Okay, it's very easy to find them. We proceed exactly as normal. We work out which quadrants do we want our answers in, and that's quadrant 1. No, it's not at all. Cos negative in these 2 quadrants. Okay, we get our key angle. So we're going to undo cos, shift cos of the square root of 3 over 2. All right, and we actually get 30 degrees. All right, and we want to be in quadrant 2 and 3. Remember, we're only going to use our horizontal axis. So one of our answers is going to be 180 minus 30, which is up 150 degrees. And the other one's going to be 180 plus 30, which is 210 degrees. Each of these can have 360 added to them as often as we like. All right, K is an element of Z. All right, but remember that in fact our angle is not theta, it's 2 theta. So only right at the end do we now divide out the 2. So our general solution becomes 75 degrees plus 180K. All right, and this one 105 degrees plus 180K. And if we had to work out between 0 and 360, there will actually be 4 solutions rather than 2. And that 4 solutions rather than 2 is because of this period being altered. The answers would actually be 75. Then we could add 180 to 75 once and we'd get 255. We can't add 180 again without going past 360. We can have 105, and we can add 180 to that and get 195. Sorry, we get 285, sorry. Okay, so there's our 4 answers. Right, now, next up, we're going to look at 2 variations which are really important. The first one looks like this. Okay, and we've got sine and cos. It definitely doesn't look very vanilla flavored at all. It looks quite complicated. We've got sine and cos in the same equation, but the big idea here is that the angle is the same in both. What we're going to do here is we're going to divide both sides by cos, right? When we divide both sides by cos, we get sine of theta plus 10 over cos of theta plus 10, all right? So we get sine theta plus 10 is over cos of theta plus 10. Right, we've got 4 here, we've got 2 here. We're going to divide both sides by 4 as well, and we get a half here. Right, this is tan of theta plus 10. Okay, and that's looking a whole lot better. Now it's a really straightforward equation. All right, we want solutions in quadrants 1 and 3 because it's tan, positive. All right, and we find our key angle. All right, I like to draw a little key key angle is equal to the undo tan of a half. We get 26.6 degrees. And because it is tan, we can just take one of the answers. Let's take the first quadrant answer and add 180K. All right, we only need one general solution. Just be careful. This is not theta. This is theta plus 10. All right. And so our final answer, if we subtract 10 from both sides, 16.6 plus 180K. Right, the next one that I'm going to do, and I'm going to do a little sort of explanation here, because I think it's one of the more complicated things in the matric syllabus, actually, to sort of really wrap one's head around. If we had, for example, sine of theta plus 20 degrees equals cos of 3 theta. We cannot here divide. It's not going to help to divide both sides by cos. And the reason being is that our angles are different. Okay, so we've got completely different angles. Okay, and the trick to this type of question is to change one of these into the other using co-ratios. So over here, I'm actually going to change sine of theta plus 20 into sine of 90 minus 3 theta. That's the same as cos, right? Using our co-ratio reduction. Okay, now we've got sine of something equal to sine of something else. Going to divert just to the bottom here, just to quickly explain something here. If, for example, we had sine of theta equals sine of 20, I think all of you would be happy to say theta is 20 degrees, all right? Or any repeat of 20 degrees. So in other words, plus 360K, K an element of Z. But in fact, there's a whole nother sort of tranche of solutions, okay? And they come from thinking about where else is sine positive. So we've actually got an answer of 20 degrees here, all right? But where else do we get exactly the same value for sine as we got at 20 degrees? And the answer is obviously going to be in quadrant 2, because that's where sine's positive. And we want to, in fact, be 20 degrees away from the 180 degree axis. So the other possibility here is that theta could be 180 minus 20 plus 360K. And that's our second part of the solution. So applying exactly the same sort of logic up at the top here, we've got theta plus 20 is 90 minus 3 theta plus 360K. And we're going to solve that for theta. I like to sort of leave a bit of a gap and write the other one down first so we don't forget it. The other possibility is that theta plus 20 is 180 minus our angle. So in other words, minus 90 minus 3 theta plus 360K. From here, and don't forget to write K is an element of Z somewhere, okay? But from here, it's just algebra. Okay, we're just going to basically solve for theta on both sides. I'm going to add 3 theta to both sides, giving me 4 theta. I'm going to subtract 20 from both sides, giving us 70. And we're going to divide both sides by 4. So we're going to get 70 degrees over 4 plus 90K. That is part of our general solution. The other possibility is this one. We've got 90 here. When we subtract 90, we're actually going to get negative. When we subtract 20, we're going to get 70 here. We've got plus 3 theta, which when we subtract becomes minus 2 theta. When we divide through by negative 2, we're going to get 70 over negative 2. It's actually negative 35. All right, minus 180K. And there's our other half of our general solution. Okay, right. Now, there are some other sort of variations. And here's one, all right? Cos squared theta minus sine squared theta. In fact, let's go with 2 cos squared theta minus 2 sine squared theta equals negative 1. Okay, now this is definitely not vanilla. There are actually choices here, all right? If we've learned our identities, we will hopefully pick up that cos squared minus sine squared is actually the double angle formula for cos. So if we start off here and we divide everything through by 2, we get cos squared theta minus sine squared theta is -1/2, right? And that's quite cool, because cos squared theta minus sine squared theta is just cos of 2 theta. Cos of 2 theta equals -1/2. This now I would say is a kind of vanilla, simple flavored trig equation. Let's quickly solve it. We'd find our key by undoing cos not of -1/2, but of +1/2. And we get 60 degrees. Which quadrants do we want to be in? Well, we want cos negative, so we're in here and here again. Okay, then our answers are going to be 180 minus the key, or 180 plus the key, plus 360k for both of them. Right, but remember that this is actually 2 theta. So we've got that. And so our final answer is theta is 60 degrees plus 180k, or theta is 120 degrees plus 180k. Okay, both of these with k an element of z. Okay, so knowing one's identities, crucial. All right, I'm going to pull up another example just for us to have a look at here. And I'm going to ask you just to think how you might solve this one. 2 cos squared theta plus 3 sine theta minus 3 equals 0. Okay, maybe someone wants to unmute themselves. If you're still there and you're still listening, I'll give you a second or two. If you can tell me how you think we might solve this, I'll have a swig of my tea while you think about that. Okay, I'm going to soldier on rewardless and regardless. And it kind of looks like a trinomial, all right? If this was sine squared theta, yeah, then it would be a trinomial. All right, and we've got a way of changing cos into sine. We know that cos squared is the same as 1 minus sine squared theta. All right, so plus 3 sine theta minus 3 equals 0. Okay, this becomes -2 sine squared theta. We've got a plus 2 here and a minus 3 here, so it's actually -1. And we've got a plus 3 sine theta. I'm not a big fan of factorizing things where I've got a negative in front here, so I'm going to multiply everything through on both sides by -1, changing this to 2 sine squared theta minus 3 sine theta plus 1 equals 0. Okay, now we're going to factorize this, and this factorizes fairly simply. You can obviously use your calculator as well, but you shouldn't need to. This factorizes to 2 sine theta and sine theta, both signs negative and both with a -1. Okay, so now we've got sine theta equals 1/2, right? Or sine theta equals -1. Now, both of these are kind of vanilla. The one on the left is slightly more vanilla and more plain than the one on the right, and I'll explain why now. All right, sine theta equals 1/2. Quite straightforward. We want to be in quadrants 1 or 2. Our key angle is just going to be undo sine of 1/2, and we get 30 degrees. And so theta is 30 degrees plus 360k, right? Or theta is 180 minus 30 degrees, which is 150 degrees plus 360k. Somewhere we need to say k is an element of z. Those are the solutions for the left-hand side. Okay, sorry, that double line should have gone here, not that. Okay, all right. Sine theta equals -1 is interesting, right? And the best way of visualizing this is actually one of the sort of extreme values on our sine graph. Our sine graph actually looks something like this, and it hits -1 at 270 degrees. So I said to you earlier that every trig ratio takes on every value exactly twice in 360 degrees. That's not exactly true, okay? The extreme values like -1 and 1 only happen once. And in fact, 0 actually happens 3 times. Right. 0 happens every 180 degrees. Right. So the general solution for this right-hand part will just be theta equals 270 degrees plus 360k. So just be aware of that. If you're at a kind of an extreme value or a 0 value, works slightly differently. Okay, I do want to keep this reasonably short, so I'm just going to do one last question, and then I'll take any questions that anyone might have. All right, something like this, cos 2 theta sine 10 degrees plus sine 2 theta cos 10 degrees equals negative a half. And the reason I keep using a number that I know is just to save using a calculator. All right, this is in fact our compound angle formula. It's the right-hand side of sine of 2 theta plus 10 degrees. Okay, equals minus a half. And I would describe this as vanilla. We want to be in quadrants 3 and 4 for sine to be negative. Our key angle comes out to 30 degrees. And so our answers are going to be 2 theta plus 10 will equal 180 plus 30 plus 360k, or 360 minus 30 plus 360k. Both of these with k, an integer. All right, and that's 2 theta plus 10. And we now solve for theta in both of these. All right, so we get 200 divided by 2. We get theta is 100 plus 180k, 100 degrees plus 180k. All right, or here we get 320, which when we divide by 2 becomes 160 plus 180k. And there's our general solution. Okay, I'm going to do what I said I was doing. That was going to be the last one. I'm going to do one more because this is supposedly, I think it's interesting, but it's not, I don't think it's that interesting. I think it's quite simple. If you've got something like tan 2 theta equals tan of 3 theta plus 10. All right, because it's tan, we can just put the one angle equal to the other angle and add 180k, and that's our general solution. All right, I do like, and I haven't done this yet, so I'll do it now. I do like to check one of my answers. All right, so here we would get negative theta is 10 plus 180k, 10 degrees plus 180k. All right, so theta would in fact be minus 10 minus 180k. All right, now I would be tempted to just check one of these answers. So for example, I'd take some weird value for k, like maybe negative 3. All right, negative 3, lots of negative 180 is 540 minus 10. I'm suggesting that 530 degrees is a solution to this original equation. Let's test it out, okay? So let's get our calculator and let's just make the calculator a little bit bigger, and let's put 530 degrees into both sides of the equation and see if it works. Tan of 2 times 530. Oh, yeah. 530. And we get negative 0.36. Okay, let's work out tan of 3 lots of 530 plus 10. Remember, we got negative 0.36. Sure as nuts, we get negative 0.36. Okay. So, yes, it was in your trials paper. It was something like sine theta equals negative 47 degrees. Oh, no, it didn't say that. It said sine theta is sine of negative 47 degrees.
Yes, sir.
Okay, that's what it said. Okay, so now this in a way is there are two ways you could do this question. There may be more, but the one thing you could do is you could actually just work out what is the sine of negative 47 degrees. Okay, so sine of minus 47. Okay, and we get negative 0.731. And I think you would agree that's kind of very vanilla, and I'm not going to bother to kind of solve that, okay, because we've done lots of these, okay? So that's the one option. The other option is just knowing this idea that if you've got sine of something equals sine of something else, either the one thing is equal to that angle, plus 360k, all right? Or the other option is for the one angle to be 180, to be 180 minus that angle. So minus 47. Okay, and there's your general solution. Okay, so this one is theta is negative 47 plus 360k. Which quadrants is this here generating solutions in? Quadrant 3, 4, 1, 2. Where's it generating solutions? Just let K be naught and just think about what solution you've got.
It'll be quadrant 4.
Well done. That would be quadrant 4. And notice from here, we are expecting answers in quadrant 3 and 4. 180 minus 47 is actually 180 plus 47, which is actually 227 degrees. Which quadrant's that one generating answers?
Quadrant 3.
Quadrant 3, 100%. Okay, so there they are. So that's how it works. So basically, even if you don't understand it fully, if you've got, okay, I'm going to go back a step. Are you happy, bearing in mind that we've got all sine, tan, cos? Are you happy that sine of 180 minus theta is exactly the same as sine theta?
Yes, sir.
Okay, that's a reduction, and it's something that we know. In fact, funny enough, I always tell you to think about theta as being positive and acute, but it actually doesn't matter. Theta can be 500 degrees. The sine of 180 minus 500 will be the same as the sine of 500. The answers for both of those things might be negative because we might be in whatever quadrant. Okay, this is a kind of golden fact. Okay, it's always true. It's true for all values of theta. Okay, so and I'm going to write down another one. Okay, and that is that cos of 360 minus theta is always the same as cos of theta. Okay, that's another kind of golden fact. Okay, so now if you end up with, okay, and I'm going to go slightly off piste here, which is a sort of skiing term when you go off the slopes. Okay, I'm not actually a skier, but I'm going to say to you, if you ended up with this, sine of lightning bolt equals sine of house. You say, in other words, you're solving an equation and you get to sine equals sine. Then, do you agree that lightning bolt could equal house? Okay. Or, remember, 180 minus house, okay, sine of 180 minus house would be the same as sine of house, wouldn't it? So in other words, lightning bolt could also equal the supplement. In other words, like that. Okay. And both of these things could go plus 360k. So all you must remember is that if you end up with sine equal to sine, then basically you're thinking an answer in quadrant 1 and an answer in quadrant 2, and the answer in quadrant 2 is going to go from 180 minus. Okay. If you end up with cos equal cos, so for example, cos of tennis ball is equal to cos of fish. Okay, then the one possibility is that tennis ball equals fish. All right, the other possibility is that tennis ball equals 360 minus fish. Or in fact, that fish equals 360 minus tennis ball. It doesn't matter which way you do that. Okay, and again, both of these can go plus 360k.